the square root of x an actual function when we're going from integers to integers? Well, we need to make sure that for this to be a function, it must follow 3 rules. First, all of the ordered pairs where we have an input x and an output x squared, it must be that the subset here, the pairs in the subset we create, are a subset, the ordered pairs we create in this set, in the function set, is going to be a subset of the Cartesian product of our integers crossed with each other, integer sets. We have to then make sure every input x is mapped. There isn't an x you can put in that has no home in the codomain of square roots. And finally, we have to make sure every x is mapped once. Every input can only have one output. Okay, so let's think about this. If we plug 0 in, right? We can plug 0 in, we're going to get square root of 0, which is just 0. So it looks like it maps an integer to an integer. If we plug in, for example, something like 1, we're going to get the square root of 1, which is just 1. Also an integer. Okay, what about if we try 2? Well, if we try 2, we're going to get the square root of 2, and square root of 2 is not an integer. So we've already found something that isn't going to be a subset of the Cartesian product of the 2 sets of integers. What else did we find? Because this is not an integer, technically it cannot map the integer 2, which means that not only is the first rule broken, the second rule is broken, because not every integer is going to be mapped. Because this doesn't map to an integer, this just won't be mapped. It'll be left blank. Finally, we don't even need to check this last statement, because everything might be mapped once, but we've already had more than enough evidence. So this is in fact not actually a function.